Matrices are a special type of vector in R, so they're not a separate class of objects, but they're basically vectors that have an attribute called the dimension. So the dimension attribute is an integer vector of length 2, where the first number is the number of rows of the matrix, and the second number is the number of columns. And so if I can create a matrix, an empty matrix with the matrix function, and I can explicitly say how many rows and how many columns there are. This is not the only way to create a matrix, but it's one way. And so when I auto-print the matrix by typing the object M and hitting enter, you'll see that it'll show me that, first of all, the matrix is initialized with NA values, so there's no values in here. And you can see that there's 2 rows and 3 columns, and they're labeled by the numbers in the brackets. If I call the dim function on M, it'll give me the dimension attribute, which in this case it says there are 2 rows and 3 columns, because the first row is the number of rows, and the second number, the first number is the number of rows, and the second number is the number of columns. If I call the attributes function on M, you'll see it returns a list where the first element is the dim element, and it has the vector 2, 3. So these are all aspects of a matrix, which is a vector that has a dimension attribute to it. Matrices are constructed column-wise, so you can think of the matrix taking a vector, and all the numbers are inserted into the matrix by columns. So the first column gets filled, and then when you hit the maximum number of rows, then the second column gets filled, and the third column, etc. So if I create a matrix by taking the sequence 1 to 6, and then I specify that it has 2 rows and 3 columns, well, how does this matrix get constructed? So the way it gets constructed column-wise, so the first thing that happens is it takes 1, 2, and now there's only 2 rows, so it can only go to 2, and then that makes the first column. The second column is made up of 3, 4, and then the third column is made up of 5 and 6. You can also create a matrix by creating the dimension attribute on a vector. So for example, I can create a vector that's a sequence 1 to 10, and then add the dimension attribute to it. So here I'm using the dim function, but I'm assigning a value to the dim attribute of M. So here I'm assigning the vector 2, 5. So what I'm saying is I want to take this vector and transform it into a matrix that has 2 rows and 5 columns. And so now after I've done that, I've got a matrix M which has 2 rows and 5 columns, and it's filled in the matrix column-wise. Another way to create a matrix, and this is a common way, is by binding columns or binding rows. And so this is column binding and row binding can be achieved by the functions cbind and rbind. So for example, suppose I have the 2 objects, x, which is a sequence from 1 to 3, and y, which is a sequence from 10 to 12. If I cbind those 2 objects, then I'll get a matrix where the first column is 1 to 3, and the second column is 10 to 12. So this is kind of what you might expect would happen. If I r-bind those 2 objects, then the first row will be 1, 2, 3, and the second row will be 10 through 12. So c-binding and r-binding is another way to create a matrix.